بسم الله الرحمن الرحيم. Still we are in this topic, which is the computing the limit at a finite number. In the first two parts, we define the limit and what the meaning of the limit, and we said that we have two sides for the limit. We have left limit and right limit. In case these two limits are equal, then we say that the limit of the function exists. If they are not equal, then we say that the limit does not exist. And we gave some theorems about finding the limit at a finite number with some examples. In this part, we are going to compute the limit of a rational function or a fractional function. So this will be the third part. We are computing the limit at a finite number for rational or fractional function. This will be part. This part, we are going to find the limit of a function f of x, and that function is of the type v of x divided by q of x, where v of x and q of x are polynomials. Then later on, we are going to give different type of examples where the numerator or the denominator are not polynomials. But for this part now, let's speak about the polynomial, a function that is defined as a polynomial divided by another polynomial. And we need to find the limit where x goes to some real number a. So the limit of f of x that equal to b of x divided by q of x, or limit of divided by q of x, where x goes to a. For the rational function, if we want to find the limit of a rational function, we will have four cases. Case number one, b of a is not equal to 0 and q of a is not equal to 0. Because as we mentioned in the second part, we said that the limit of the polynomial is just direct substitution of the variable x. Limit of b of x equal to p of a, limit of q of x equal to q of a. So if we want to find the limit of a rational function, we just replace x by the given number, that's a. So I will have b of a divided by q of a. Now, b of a and q of a can attain different type of values. The first case, that b of a is not equal to 0 and q of a is not equal to 0. In this case, the limit of v of x divided by q of x is just simply v of a divided by q of a. So this is the first case. Where the numerator and denominator are not equal to 0. Second case, case number 2. b of a is equal to 0 and q of a is not equal to 0. In this case, the limit of b of x divided by q of x, where x goes to a, is equal to b of a divided by q of a. b of a is equal to 0, so this is 0 divided by q of a, which is equal to 0. So the second case, when the numerator is equal to 0 but the denominator is not equal to 0, the limit is equal to 0. Third case, v of a is not equal to 0, but q of a is equal to 0. So in this case, the limit of v of x divided by q of x, that will be v of a divided by q of a, which is v of a divided by 0, but in math, dividing by 0 is undefined. So the limit for, in this case, if the numerator is not equal to 0, but the denominator is equal to 0, we say does not exist. Don't confuse between the value of the function and the limit. The value will be said as undefined, but we will say about the limit does not exist since we are dividing by 0. So when x goes to 0, either it will be plus infinity or minus infinity. It is another way to say the limit does not exist. For the fourth case, case number 4, v of a equal to q of a, and most of them are equal to 0. v of a equal q of a is equal to 0. So in this case, the limit will be 0 over 0. And 0 over 0 is one of the undeterminate cases. So if we got this form 0 over 0 after we substitution or replacing x by a in the numerator and denominator, I will get 0 over 0. In this case, we have to simplify the rational function. So in this case, we need to simplify. Simplify means removing the 0 from the numerator and from the denominator. And in general, for the simplifying means we are removing the factor x minus a. We'll see later on in the example that x minus a will be one of the factors, will be common in the numerator and the denominator, and if we simplify it means we will remove x minus a from numerator and from the denominator. It is this part, x, this one. If we move a to the other side, I will have x minus a, and that will be a common factor between numerator and the denominator. Now let's take some examples to make this idea clear. Find or compute the limit. Number 1, limit of x minus 5 over x squared plus 4x minus 3 as x goes to, let's say, 2. I have rational function. So it is polynomial divided by another polynomial. So first step, try to substitute. Replace x by the given number. Replace x by 2, and then you can decide which case it is. Is it the case number 1, 2, 3, or the fourth case? If we substitute x by 2 or replace x by 2, I will have 2 multiplied by 2 minus 5 divided by 2 square plus 4 multiplied by 2 minus 3. That will be 4 minus 5 is equal to minus 1 up, and down I will have 4 plus 8 minus 3, that will be minus 1 over 9. So the limit is minus 1 over 9. This is the first case, where the numerator is not equal to 0 and the denominator is not equal to 0. Take another one. Number 2. Let's find limit of x squared minus 4x plus 4 divided by x squared minus 9, where x goes to 3. x squared minus 4x plus 4 divided by x squared minus 9. So first step, substitute, replace x by 3. So this is equal to 3 to power 2 minus 4 multiplied by 3 plus 4 divided by 3 to power 2 minus 9, which is equal to, I will have 9 minus 12 plus 4 divided by 9 minus 9. And that's it. 9 plus 4 is 13 minus 12 is 1 over 0. And as we said before, we can't divide by 0. This is undefined, which means the limit, so the limit does not exist. So the limit in this case does not exist because the denominator is equal to 0, but the numerator is not equal to 0. One more. Number 3. Limit of x squared minus 7x plus 12 divided by x squared plus 5x minus 1. And let's take x goes to, for example, this time 4. Limit x goes to 4 of the given function. So as we mentioned before, in this case, I'm going to replace x by the given number, which is 4. So I'll have 4 to power 2 minus 7 multiplied by 4 plus 12 divided by 4 square plus 5 multiplied by 4 minus 1, which is equal to, I will have 16 minus 28 plus 12 up divided by 16 plus 20 minus 1, and this will give me 0 divided by 35. Is 0 divided by 35, which is equal to 0. So the limit in this case is equal to 0. Where the numerator is not equal to 0, I'm sorry, numerator equal to 0, but the denominator is not equal to 0. So it is 0 over 35, which is equal to 0. For example number 4, let's find the limit of x squared minus 7x plus 12 divided by, let's say, x squared minus, that will be x minus 6. For x goes to 3. Find the limit of this function where x goes to 3. So let's try to substitute first. I will have 3 to power 2 minus 7 multiplied by 3 plus 12 up, down, 3 to power 2, which is 9, minus 3 minus 6. Now, this will give me 0 over 0. I will have 0 over 0. Now, 0 over 0, I cannot decide about the limit now. If it is in this form, we cannot find the limit unless we do something for this function. So in this case, if I have 0 over 0, I will simplify the function. Since I have polynomial divided by another polynomial, I'm going to factor it out. So we need to simplify. Okay, So this will be limit. The numerator can be written as product of two factors, also down. So limit as x goes to 3, numerator will be written as product of two binomials, and also the denominator will be product of two binomials. Now the first one, as we mentioned before, it is this one. X goes to 3 can be written as x minus 3. So the first factor will be this one. This one. So I will have the first one is x minus 3. Up and down. And this needs thick line. I will have x minus 3. Up and down. This will be the common factor. It is this one. X goes to 3, so I will move 3 to the other side. It will be x minus 3. So I must have x minus 3 up and x minus 3 down in this function. Now the other factor, it is x squared minus 7x plus 12. It is x minus 3 multiplied by x minus 4. This is the numerator. These are the factors of the numerator. X minus 3 multiplied by x minus 4. Divided down by x minus 3 multiplied by x plus 2. This is by factoring. Now you can see that I have common factor, which is x minus 3. So we can remove x minus 3 from the numerator and the denominator. I will have limit of x minus 4 up and x plus 2 as x goes to 3. Now what we need just to replace x by the given number, which is 3. Replace x by 3. We will have 3 minus 4 divided by 3 plus 2. That will be minus 1 over 5. So the limit for this function is minus 1 over 5. Okay. So you can see that if we have 0 over 0, we have to simplify it. If I have polynomial divided by another polynomial, so we just factor it out. In some cases, we have different type of functions, maybe radicals. But in this example now, I have polynomial divided by another polynomial. Let me take another example. Number 5. Let's find limit of x squared minus, let me choose this time, 25. And down x squared minus 3x plus 10, where x goes to 5. So this should be minus 10, not a plus. X squared minus 25 divided by x squared minus 3x minus 10. So as we did before, replace x by 5. See, what will we get? I will get 5 squared minus 25, which is 0, divided by 5 squared minus 3 multiplied by 5 minus 10. You will get 0 over 0. So it is 0 over 0 means I have to simplify. So we need to simplify. So this function or limit will be written as limit of x squared minus 25. We are using difference between two squares. A squared minus b squared can be written as a minus b multiplied by a plus b. So the numerator will be written as x minus 5 and x plus 5. Down, x squared minus 3x minus 10, as we mentioned before, I must have x minus 5. It is this one. It is this one. We must have x minus 5 as a common factor. So I have x minus 5 as the first factor. The second one, it will be x plus 2. This is by factoring. I can say by factoring. Now, I have common factor. I will remove the common factor from up and down. It is x minus 5 from the numerator and x minus 5 from the denominator. So I will have limit of x plus 5 divided by x plus 2 as x goes to 5. Now substitute, replace x by 5, I will have 5 plus 5 divided by 5 plus 2, so it is equal to 10 divided by 7. So the limit for this function when x goes to 5 is equal to 10 divided by 7.